6.4, the fundamental theorem of calculus. Now, if you haven't noticed, and I wouldn't expect you had, I've noticed all year long that we kind of do things once and then we do it again. So we've already done a lot of this. Now we're going to officially connect integration and differentiation, which is nice because we know how to differentiate. Now we just have to do the inverse process. So if we call an integral a capital F, the antiderivative, and if we put points on it, we call it the definite integral. If we take the derivative of that, we get right back to the function. Now be careful here. And they talk about there's the derivative of every point in. Yeah, no kidding. Here's the x, here's it goes. Well, what happened to the a? The a vanishes. So let me try and show you this. I will actually use the letter a even though I don't want to. Integral from a to x of x, not a function, just of x, is x squared over 2. Prove it. Derivative 2x, 2's cancel x. Cool. So the law from a to x equals, plug in x for x, which is weird. We should really have a dummy variable here like u du, whatever. X squared over 2 minus a squared over 2. There's our answer. Well, here it says, now take the derivative of that. You should get the function, and they did have a dummy variable. Well, might as well be precise. T to t dt. And then we get t squared. Sorry, I can't help myself. But I have an x and a constant. This is going to be where things get messy, where it's both constants, neither is constant, so on and so on. Take the derivative, change colors on this, of what we got. Derivative of what we got. This is where I keep screaming and yelling at the top of my lungs. What's a constant? What's a variable? This a squared is a constant. That's gone. It's 0. Derivative of this is 2x over 2, just x. And there's our original function. And we use the dummy variable in there. We get back to where we started. So what does this say? And it's kind of important. If I have a continuous function, it's derivative of some other function, meaning I can find every continuous function, I can find an antiderivative. These processes are inverses. Oh yeah, I got x. Careful. That's, careful. I'll just leave it at that. Only got x because that was the original function. If we put these together, we should get x every time. We don't. We get the original function. So, examples. Now, I'll do this the long way just to help you out, but I won't keep doing it the long way. You should be able to go derivative, integral, cancel, plug in the x because that's a constant. But here's what we get. Leave the derivative sign for now. Integral of this is sine of t negative pi to x. Give me a moment. Still, I'm not taking the derivative because I have to go sine of x minus sine of negative pi. And you might say, well, plug that in. What is that? I don't know and I don't care. So when I take the derivative of sine of x is cosine of x. Derivative of a constant is 0. So I could do arctangent of x, arctangent of 0, and blah, blah, blah. I don't have to. They're going to cancel. And I'm just going to end up with now here's the problem. That's not how it always happens. So be careful. All right? Be careful. Show you that momentarily. So go ahead, try it again. If dy dx is this. Well, this is not x. When I chain rule this, because I'm going to take a derivative of an integral, something funky is going to happen here. So it only is nice when we have an x, and this one, the x is on the bottom. So it's only really nice when we have an x on the top. So let's do this the long way, just in case. Y equals integral of cosine is sine 1 to x squared equals sine of x squared, and your brain might be screaming right now, what about chain rule? No, we're not taking a derivative. There's no chain rule. Just plug it in. We get that. So now dy dx, sine of x squared is cosine of x squared times 2x. So notice how things have changed. If that was just an x, it'd just be an x. Plug in, we're done. Derivative of sine of 1, gone. So I will just put it out front because I'm a nerd. There we go. I found this problem incredibly confusing. You might be like, well, it's not a big deal, just do the integral. Well, they're going to give us problems like this one where we can't do the integral. That's mean, but you know, they're just testing if you know the fundamental theorem of calculus. What if the variable's on a lower limit? Let's see who's smart enough to figure this one out. Oh, that's right. We can flip them and slap a negative out front. Y equals negative. And by the way, notice the problem. Find the integral, man. We can't do that. We can't. We haven't practiced that one yet. It's using something called integration by parts. Find the derivative of the integral. Oh, yeah, they cancel. I'm off to the races, but I got to be careful. I know they're going to cancel out when I find dy dx. So negative comes along for the ride, 3x, sine of x, done. This is when people start squawking. Well, what happened to the plus c? Definite integral, there's no plus c. Well, what happened to the chain rule? You have to, you know, or the product rule, integral, derivative, inverse functions, just plug it in. Well, what happened to the 5? When I took the integral and I took the derivative, it canceled out. So hang on tight. That's why you got to get this basic stuff because it gets nasty. Let's change this because we don't have a constant in here. Let's change it from 2x to 0, 1 over 2 plus e to the t dt, plus integral 0 to x squared, 1 over 2 plus e to the t dt. Equals, well, not yet. No, I guess I can. Oh, gotta fix this one. Negative integral 0 to 2x. I'm gonna save myself some drawing space, put the dt on top, just to make life a little bit easier for me. Plus integral 0 to x squared dt 2 plus e to the t equals, we're going to plug that in and we're going to chain rule it 2. Negative 2 plus e to the 2x plus x squared. So we're going to have a 2x, 2 plus e to the x squared. Boy, does this take some getting used to. I mean, this is really, really tricky. So find a function. This would be where I would pause the tape. Find a function y equals with a derivative equals tangent of x. So this is stupid. I mean, this is completely unuseful, but you know, whatever, we'll figure it out. Let's just take a second. That's x and that's my y. Okay. So a function with a derivative. Okay, the function is integral of tangent of x because they're going to cancel out dx. But when I plug in 3, I want to get out 5. So 3x plus 5. Because when I plug in 3 to 3 is gone 0. I get out 5. Plug in 3 to 3 is 0. Now, you might be like, I don't know what just happened. And it seems like you're just making up problems. And I'm sitting here going, yeah, you have a good point. You have a really good point. What if we actually knew how to find the integral of that, which I do. It's a natural log thing. We'll do that in the very near future, so don't worry about it. Oh, look, it's a natural log. It's a negative. I don't know what that's all about. Probably something to do with the cosine. Where'd the cosine of 3 come from? Oh, so let's say we took the derivative of that. Dy dx equals negative And then it'd be 1 over cosine of x over cosine of 3, which we would flip. So it'd be cosine of 3 over cosine of x times derivative of this. Inside that's 1 over that. Then derivative of this is derivative of cosine is negative sine of x. And then that just comes along for the ride. And the derivative of 5 is gone. So these cancel, this cancels, and I end up with tangent of x. Hey, look at that, it worked. What the heck just happened? I have no idea. Why is it cosine of 3? Why not just leave nothing there? Oh yeah, because of that whole thing on the previous page about something about when I plug in 3, I get out 5. Oh, it's gonna get me out 5? Yeah, cosine of 3 over 3 is 1, natural log of 1 is, oh, okay. How the heck did you, don't worry about it. Don't worry about it. I'm actually gonna write that in my notes. What we need to think about, and I know I've talked about this in class. By the way, that's a much harder problem than I would ever expect anybody to ever have to do. What we need to think about is, how do we actually get this to work if we didn't have all this skill? If we just had that previous page? Well, we can actually put it in the calculator. So I don't know if I'm going to do this. Consider the function 3 to x, graph it. All right, probably going to wait a long time. Hit the off button if you need to stop the process because it's going to go over and over. Now recall the graph of y equals 10x has vertical asymptotes at negative pi over 2 and pi over 2 where they occur. So I'm going to let you play with this, right? But notice you can do all this math without knowing how to find the actual integral because you have that ability to graph a nint. You can just go up here and plug it in. Math 9. You can plug in 3 to x tangent, and we don't have a dummy variable. We can use x anyway on the calculator, which is annoying, but such is life. We could just graph this and play with it, which I want you to do. I'm not going to do it here. All right. So just gives you some things to think about. I'm not, again, not going to go into all this. Just let you play with that on your own. It's kind of nice to know, oh, I just have to understand how to use my calculator. I can do a lot of damage here. Anyway, so this is part 2. All right. And this is what we've already done with building the wall. All right. If we know it's got an antiderivative on the whole interval and it's continuous on the open interval, then and you don't have to know those definitions. For a lot of other stuff, it's like, oh yeah, is it open? Is it closed? Is it differentiable? Not going to pop up. All right. Go ahead and build the wall. So this would actually be f of x, the antiderivative, a to b, which is, as we said, f of b minus f of a, and run with it. So we'll check this with our calculator. We'll see how good a job we do. Antiderivative, add 1, x to the 4th, divide by whatever we get, plus x. How do I know that? Derivative of x is 1. Parentheses, because we have that wall thing. A lot of times we get to ignore the bottom. This is not one of those times. I do the brackety thing. 3 to the 4th over 4 plus 3 minus negative 1, parentheses around that, to the 4th over 4, always parentheses around your negatives, plus negative 1 equals 81/4 plus 3. Watch this. This is going to get a little weird. Minus, distributing this, minus 1/4 plus 1 minus 1. Well, 81/4 minus 1/4 is 80/4, which I believe is 20, plus 3 plus 1 is 24. Got to be able to do that by hand. But hey, while we're here, can't see my hands, but you can see what I'm doing. How about we just do this math 9 from -1 to 3 x to the third, carefully get down off the third. I often forget that, plus 1 dx, we should get 24. Our calculator is actually exact in this. Sometimes it is, sometimes it isn't. So if you got 23.999, you know you did it right. Find the area of the region between the curve and the x-axis. Now, gotta be careful here. They want the area of the region. I gotta graph it, find out what's going on here. 4 minus x squared. It's up here at 4. We're going 0 to 3. Well, I know if I plug in 2, I get 0. So 1, 2, 3. So we're coming down here. We'd like some numbers. All right. So if we want the area, I had to do this twice. Get it from 0 to 2. Because that is above the curve. It's going to give me a positive area of 4 minus x squared dx. And then I have to do it from 2 to 3, negative 2 to 3 of 4 minus x squared, because I know I'm going to get a negative answer. So just subtract it. Very messy math here. 4x minus x to the third over 3, 0 to 2, minus 2 to 3, 8 minus 2/3. These are both 0 out, minus 0, minus 0, just to show that I actually did it. Minus, careful here, this one will not just disappear. 4 times 3 minus 3 squared minus, and I'm going to go with a plus negative plus, because that's going to cancel out. Notice how messy this is. 4 times 2 minus 2 squared. Whew. I don't know about you, but I'm tired. Equals 8. I'm going to avoid my 2/3 as long as I can. 4 times 3 is 12 minus 9 is 3 minus 3 plus 8 minus 4 plus 4. I feel like I've made at least a dozen mistakes in there, so we'll see how this goes. 8 minus 3 plus 4 is 9 minus 2/3. 27/3 minus 2/3. Looks like I made a mistake somewhere. Gotta be careful here. 8/3. How did I do that? 8/3. 8/3. That's wrong too. Woof, I made 2 mistakes here. Goodness gracious. I didn't actually take the integral here. This happens to me a lot when I'm making videos. I just overtalk it. The good news is I wrote it all out to make it as easy as possible to clean up my mistakes. 8 minus 8/3, lovely. Minus, let's cross all this out. 8 minus 8/3. Minus 12, I have to distribute this, plus, that is a 3/3, 9 to 3 is 27 to 3, plus 9. This is crazy. Plus 8 minus 8/3. Wow. All right, one more time. That's negative 3 plus 8 is 5. 8, 13, and we'll find out if I did this right in a minute. 13 minus 16/3. 3 times 13 is 39, minus 16, and my brain just scrambled up, so I'm actually gonna put it into my calculator. equals, this time I got it right, 23 thirds. Okay, let's do it with a calculator. Wait, I have to break it into two. That'll take forever. I'm not in the mood. Is there a simpler way to do that on my calculator? Well, let's keep that around. See if there's a simpler way. What if I put an absolute value around this thing? Saw what happened then. Let's try that. Clear. Math 9 from 0 to 3. Math absolute value 4 minus x squared dx. It's going to take its time. Give me 23 thirds. So I can put an absolute value around here. That's pretty cool. So here's another one. We actually have the skills to do the antiderivative here, but not yet. Let's try it again. Let's try the absolute value then. So just for those who might have missed it, negative 3 to 3. Integral negative 3. Negative 3 to 3. Absolute value x cosine 2x. dx. Can I be lazy? A little bit. Negative 3 to 3. Delete, 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 delete. X cosine 2x. Taking its time. Wow, that's taking a long time. So the spinny yellow thing, still going. And that happened to know is correct, 5.425. So don't panic, I guess is the word when your calculator does that. So is there a rule we should remember when it says area? And that's a pretty handy rule, but it really comes back to RTFQ, reading the full question. All right, consider the graph of f to the right with the domain 0, 8, where h of x is the integral of this graph. That's f. So wait a minute, I thought we were just getting used to doing, that's a derivative graph, and now you're doing the integral? Oh, that's horrible. Yeah, exactly. So h of x starts at 1 and goes to the right. Find h of 1. H of 1 equals the integral from 1 to 1 of, oh, that's just 0. Please know that because it pops up a lot and it really will really help you out. All right. Is HO positive or negative? Now, it's above the graph going from right to left. It's going to be negative. Right. So this area here is above the graph, but if we start on the right, go left, negative. Prove it. Well, I could also say it equals negative from 0 to 1, f of t dt, which is positive, going from 0 to 1, it's above the graph, also negative. Which, by the way, a lot of people ask me, well, how come it's negative when you go from right to left? I just proved it. I just proved it. All right. Find the value of x, which h of x is a max and a min. So starts here, goes to the right, accumulating area all through here. As soon as we get past this point, it starts losing area. So we are going to say that I'm starting at 1. Of x, which of x is a max and a min. Going left is a min. We're going to have a little min here, but they want the max, the global max. Even though we don't say so, we're going to assume that. This area here is going to be much bigger than the little red area over there. So max occurs when x equals 4. The min, so we have this area, and now we're accumulating min area. So that's actually got to be careful. Going from here to here is all negative. But I think this whole area minus this area is still going to be bigger than that area. So we'll make that assumption. Min occurs x equals 8. Of course, in the real world, we'd have to check those endpoints, make sure. Find the x-coordinate of all points of inflection on the graph. So that's where the, this is, oh boy, on the graph y equals h of x. Let's slow down. Derivative of h of x is just the function. This is the graph of the derivative of h of x. The derivative of this graph would show me where the POIs are. So it's peaks and valleys on this graph. So this, come all the way up, POIs at 1, 3, and 6. Confused yet? Well, this is why you got to practice. This is extremely challenging stuff. Good luck, and as always, happy mathing.